Hey everybody, it's Mrs. Hofferberth. Let's talk about atomic notation. Atomic notation is used to convey information about what element, isotope, and particular charge an atom is, and also from that information we can figure out how many protons, neutrons, and electrons are in an atom. The picture on the screen here is an example of an atomic notation symbol. So you'll see in the middle you have the element symbol, and then there are three numbers around it. The number on the bottom left is called the atomic number. The atomic number indicates how many protons are in an atom and therefore specifies which element it is. The number at the top left is called the mass number. This indicates the mass of the atom, and it is due to the heavy parts of the atom, and so that mass is equal to the number of protons plus the number of neutrons present in the atom. And so this is going to tell you which isotope you have of a particular element. The number in the top right corner, that is the charge. The charge is the difference between the number of protons and electrons you have. If you have more protons, you will have a positive charge. If you have more electrons, you will have a negative charge. But it's that difference that will determine the charge. And this number is, for convention reasons, written as the number and then whether it's positive or negative. So 1 minus rather than -1, and that's just convention. People have just agreed that's the way they're going to do it. Atomic notation is very useful. It's a really nice shorthand, and you'll actually be able to go back and forth from protons, electrons, and neutrons to the atomic symbol itself and interchange between those. That's your goal. So let's take a look at 3 examples where we're doing this. The first example on the left, I've given you a symbol for atomic notation. And so you'll see it says titanium, Ti, 4822, and there's nothing written in the top right corner. If there's nothing written, that is assumed to be 0. So I'm going to write this in for emphasis, but if nothing is there, this is 0. So from this, we can start completing the table down below. So atomic number. The atomic number is the number in the bottom left corner. This is 22. Mass number, that's the one in the top left corner. This is 48. And the charge is that top right corner, that is 0. Those are kind of the names. What they correspond to in the molecule, protons, neutrons, and electrons, is what we're going to figure out next. The number of protons depends on the element, and this is your atomic number. So titanium, which has an atomic number of 22 on that periodic table, has 22 protons. The number of neutrons can be found by subtracting the mass number, which is protons plus neutrons, minus the atomic number, which is protons, to get the difference. So we're going to take 48 minus 22, and we get a total of 26 neutrons in this atom. The number of electrons, we're going to look at the charge. The charge is 0. So that means that I've got the same number of electrons and protons. Since I had 22 protons, I have 22 electrons. The second one here, I've given us atomic number, mass number, and charge number. So if you're going to turn this into atomic notation and then into protons, neutrons, and electrons. If the atomic number is 30, you're going to look on the periodic table and find element 30. This happens to be zinc. So I will write Zn in the center of my atomic notation symbol. From here, I'm going to put my numbers around it. So atomic number goes in the bottom left. I'll write 30. Mass number goes top left. That's 68. And the charge is 2+. Let's combine protons, neutrons, and electrons. Again, the number of protons is the same as that atomic number. So in this case, 30. The number of neutrons is the difference between the mass number and the atomic number. So I'm going to do 68 minus 30, and this is 38 neutrons. And then the number of electrons, we will look at the charge in that top right corner. This is 2+. This means I have 2 more protons than I have electrons. Since I have 30 protons, I must have 28 electrons. Last one. Let's go backwards. Starting with number of protons, neutrons, and electrons, Let's find out our atomic number, our mass number, and our charge, and then write the atomic notation symbol. Since there are 53 protons, that is our atomic number, 53. The mass number is protons plus neutrons. So I'm going to add 53 to 74, and that is 127. And then for charge, I'm going to compare protons and electrons. In this atom, I have 53 protons and 54 electrons. The difference is 1. And I have one more negative electron, so this has a charge of 1 minus. Now I can write my atomic notation symbol. I need to figure out which element is number 53. That's iodine. So I'm going to put I in the middle. My atomic number goes bottom left, mass number top left, charge top right. So atomic notation is a nice way to summarize key information about your atoms. So what element they are, what their mass number is, so what isotope you have, what the charge is, and from there you can find out things like protons, neutrons, and electrons, or backwards and forwards.